operator, so we have seen, and we have also seen how do we filter a data, filter a relation, okay, based on some conditions, and conditions we can give. And we have also loaded some data set and try to work on that. And how do we find a distinct files from a relation, order by, group by, all these things, co-group. Okay, those things we have seen. So today we will see join and the loop for each. Okay, so how the loops works for each. Likewise, how do we get some data from the relation for each, that we will see it. Okay, I will open share my terminal. Okay, this is another machine I am using. Okay, because data are present in this, I couldn't switch. That's why I am using this machine. So here I will quit it. I have so many files in this pick directory, pick dir. Okay, so I will take some text files on all, custom and all. It is already present, so I will be using it. Before that, we will see joins. Okay, joins we know, right? In MySQL, we have joins. We have seen joins. Joins are used to join the two table, and it will give a results. So there are types of joins inner join, left join, right join. Right join is the left. Um, okay, yeah, right, left join, right join, and full join. Okay, these are the four types of joins which are available in Pix. So here, if you are going to join, then you are going to join between the two relations. That's what it is going to be the idea. You cannot join the complete data set. Okay, so we will for this we will use two text files which are nothing but vi, something like a cust file is there, cust.txt. Okay, so this is a other file. One other file I will use is order.txt. So these two files contains information like customer information. Okay, customer information is, one minute. Okay, customer information about who are the customers, his age and his city and the amount he has spent. Okay, and his serial number. Hope you can see my screen, right? I'll put it in the scale. It's fine, no? Screen is okay. About the customer, and this customer, what are the purchase he has done? Okay, that I have it in the another table. Okay, like a customer ID 102. He has done this purchase, that purchase, and all. One minute, in customer we don't have that ID, right? Underscore one dot txt, yeah. Underscore one dot txt is having ID like 101, 102, and all. So I'm going to join uh, uh, these two data set into one and find the common joins and left join, right join, and full join. I hope you remember left join means the the relation which you are given in the left side completely will be taken, and whichever is common with the right table, or the here it is a relations, right relations, that it will give us a result. Right, full join will give the result of both the relations. Right join will give the result of a right relation completely, and common with the left relation. I will show you. Okay, don't worry. First, in order to use this text files, we need to load this, right? We need to launch our pig pig shell. Okay, I'm going to use it in the pig-x local. I will show it in the next class about the map reduce. Okay, and the map reduce is where we can put your data in directly into a HDFS. Okay, so here I have to load customer data and the ordered data. Since I'm in pick directory itself, I don't have to give the path completely. So what I will do, I will load ordered data. Okay, order the data, create a relation and load the data. Load. The file name is order.txt, right? ord.txt. Okay, ordered order.txt, and using pick storage. Sorry, it should be comma separated. Okay, as what is the schema I'm going to give? It is having a id, order id is of a type int, and it has a name which is of type a char array. Okay, in a pig it is a char array, and it has a order id. Okay, oid, and which is an integer, again I will give, and the price which is a char array. Okay, so this is the schema I have given for my order ID table. I will open the table also. Okay, CLS VI order ID, order.txt. So order ID, snack, and the another one, four columns are there. OID, ID, okay, and price, everything I have given it here. Okay, so we will enter it. It is fine, it is an info only, it is no error. So it is loading is done. How do we see it? Dump and check the data. See, all these things are loaded in the form of a tuples. Each one is the tuple over here. Okay, so I also have to load the customer data. Okay, like I will give the name relation as a cust data equal to load uh, cust date underscore, file name is cust underscore one, I think, one dot txt, using quick storage. Oh, sorry, comma separated. The file is comma separated, and as what are the fields it is having? Uh, Customer data, I forgot. We will check it. Vi customer underscore one. It is having ID, customer ID, name, age, everything we can give. So CID as integer, and name as char array, and age as integer, and what else it was having? City as char array, and finally amount as integer. Okay, this is the schema. Okay, it is created. Now how I will check it? Dump the customer data, cust underscore data. Okay, it is all dumped. Now it, the relations, what are the relation? Two relation, cust underscore data and order underscore data is going to have the data. Okay, we will use this relation only to work on it. Okay, so what we will do first an inner join. Inner join I will give like some name, that also will store the data. Once after joining, it will give the result, right? That will be stored in your relation. Okay, so I'm giving inner join, or inner join only I will give. Inner join equal to join. This is how you have to write it. Which are the tables? Cust underscore data relation, by what you are, in join you have to give, no, by what ID you have to do. You are going to join by CID. Okay, comma, the other relation is order underscore data by ID. Okay, so if you see the table, see what I'm doing. It is easy, this command, when compared to SQL itself, this command is very easy. We are going to join two relation, custody data relation and order data relation. Okay, if you see the join in MySQL also, you will be joining two table based on an ID. On you will write, okay, on this to this. So likewise here we are joining it. See, data ID, common ID. This is the customer table. Okay, This is the customer table. Control G. Okay, customer one table. Okay, in this table we have this CID. No, this ID we are going to match it with our order ID. Okay, order id oh id of the second table. Okay, so this is the inner join. What it will do, whatever is common between the two relations, it gives that as the result. See, 102 is there, 100 is there, 101, 103, 104 is there. So all these results it will give. 101, 103, 104, whatever is matching with the id, it is going to give us the result. Okay, because it is an union. Okay, union A union B, not A union, intersection A intersection B, because common of both the tables or both the relation it will give, so it is intersection. Union means all, full join. Yeah. Okay, it is done. But how do we execute that command? The dump inner join. Okay, we'll see the result. See it, whatever is a common, 101, if you can see the table, 101 is here also. What are the results present? 102, 103, and 104. Only four are present, but the customer table is having 106, 105. It is not in present in the matching relations of order ID, right? 106 and 105 are there, not there. So those results it is not printing. Okay, all it is accumulated into a single tuple. Okay, the first relation. This is from the customer relation, this is from the customer relation, and this is from the order relation. Both are aggregated together into a single tuple, and it is giving us the result. Okay, guys, joins are fine, no? Okay, next what we will do. So this is inner join. We know it. How to do left join. Okay, left join means all the relations. If I write left join, I will write the left join. Left join I will give equal to uh, join cust da- cust underscore data relation. This is the relation. It is containing the values by CID. Left you have to write. Okay, left comma order underscore data by ID. Okay, the common field I am going to join it. What this command will do, left join means all the data from the left relation will be listed, and whatever is common between left and right relation will be listed. Okay, this will be like a uh, whichever is common. No, a plus if say cust data plus cust data intersection of order data. See, this is how the result will be. I'll write it in a note. One more, sorry. Yeah, that's right. Amlan has written a plus a intersection b. It will be like that. Okay, just a minute. Okay, so if I enter it, it is throwing error to me. What is the error? Left cust. Join cust data by ID left comma. This is right. Okay, I will try to give some other relation name. Still it is giving error. Join left equal to join cust underscore data by cid left, comma, order underscore data by id. Now it is fine. Why it is not taking before? Cust data cid. Okay. The syntax is fine only, but before it was not taking. Okay, it is expecting a space. That's the reason it is not taking. Okay. Otherwise, if we give left join also, it is a fine. Okay, no syntax error. See, you can see, right? When we are doing some errors, no, it will give semantical parsing, it will be doing it. Okay, only but execution it will not do true. Only if you do a dump, it will start the execution. So what I will do, dump left join. Okay, so if you see it, okay, you can see the result. Whatever is present in the table in the relation customer data, it is giving along with whatever is matching. Okay, but for 105, there is no matching record in order table, so it is giving comma, comma, comma. Like that only, it will give the result. Okay, similarly, like a right join, it is same thing where you will give. It is easy, right? You don't have to remember. So working with the pig is easy, right? Easily you can write it. Right. Okay, right join, customer data by CID, right order ID by this. Okay, enter it. So dump and check. Dump a right join. See, whatever is not matching with the left table, it is not giving. Otherwise, all the data from the right table it will give. Okay, right table means a right relation, and and whichever is matching with the left also it is giving all the data from the right relation, which is order underscore data. Whichever is matching with the cust underscore data also is it will give. Okay, see if you change the order. Okay. S- okay, if we change the order also, it will give a different result. So same thing in the right join or in the left join. If you give this relations order, then it will give accordingly based on your requirement. You can take this. Okay, you can change this order, cust underscore order. I just changed the relation names back and forth. Then we will see it is throwing error for me. Okay, this cust data is having a relation CID, right? Say it is throwing error saying some schema only does not exist. Okay, so we can check the schema. Describe um, cust underscore data. See, it is having CID, but cust data I have given ID, and order data will have ID, right? Order data will have ID, but I have given different way. That's why it is giving error. So we'll change this. Okay, so now it is a fine. Dump a left join. Okay, now it will give the results from the order table first completely, and whatever is matching with the cust data relation. Okay, full join we will see the same thing. Where we will give the full. Okay, full join. Full join equal to order and the cust data relation as a full you have to give. Okay, full join, they will also say it as a full outer, or you can also give it as full. Full, I'm not sure whether it will take. Yes, it is taking. Otherwise, they will call this as a full outer join also. Okay, outer. Okay, so if I dump this and see, it gives the kind of a cross join for uh, cross join in MySQL we have seen. No, it's a Cartesian join. Likewise, it will give whatever is matching is coming. Otherwise, if it is not record is not present for 105 in order relation, right? So it is not giving that result. Okay, so joins you can use to join two relation. Co-groups also you can use to create combine two relations and group it by a particular city or a particular field. Okay, likewise you can work. See, now from this on you can see, right, working on a structured data using a pig is very good. That was one of the advantages also. So this kinds of joins you cannot put easily on the video files or images. That's why it is told like that. Then afterwards what we will see, um, okay, before going further to uh, for each and all. And also guys, this outer joints, right, same like in SQL, they can be also be called as a left uh, right outer join and left outer join. Okay, the left outer join which we are giving, no, left outer join, you can also put it as left outer join, both are same only. Okay, both gives the same result. Otherwise a right outer join also you can write it. Okay, internet also called, sometimes if they ask, tell about right difference between right outer join and right left outer join. Left join, right join, both are same. Left outer join, right outer join also can also be called like that. Okay, so now what I will show. Okay, we were talking about the complex data model types in a pig, right? In that, we told like we can store our data in the form of a tuple. Store means load our data in the form of a tuple or in the form of bags. And the next definition is bags. So I will show you how you can store your data in the form of a tuple. Tuple in the sense, we are giving the schema, right, for a load. While loading we are giving the schema, right? So how do we give it this schema in as a tuple, that I will show you. Okay, so there is something like sample.txt, I think. Sample.txt file is there. So if we take this a file, how do we store this in the form of a tuple, we will see it. Okay, or we can take any file, our datas only, we can take it and we will see. Okay, so I will take some. Yeah, this one is there. Say the data is present in this way. Okay, in your data set as a tuple. This I'm going to load it in your data set. That I will show you. Okay, tuple is like in the brackets that they have given the data, right? So how am I going to store it in the form of the tuple? That I will show. So what I will do, we will write a new loading statement. In that, say for example, I'm going to load the data in tuple. Okay, tuple input. Likewise, this is the relation name. In that load, my file name is tuple.txt. Okay, using the pic storage as how to give the schema definition for a tuple is tuple. Okay, and inside it, you are saying that it is going to be a tuple. Inside it, you are going to say that whatever is the field names, int. Okay, and name as a char array and age as int. Okay, this it was containing three fields. Okay, name, uh, id, name and age if you consider like that. So those things I'm saying that it store load it in the form of tuple. This is like if you think like you are getting a data set which is in the form of a tuple, then how do we load it? Because a pig allows you to load data tuple based data, so right? So I have loaded it. In that you will specify before you are giving the schema definition as a tuple. Enter this. It is not a problem at all, it is just an info. So I will dump it and check how that data is loaded. Tuple input, my relation name is tuple input. Tuple.txt data is loaded into tuple input relation that I'm going to dump it. It is not taking properly. I think there is some problem. I will try again. I small letter I have given capital. It is not taking that data. See, it is not giving the values from the data. Okay, that is what I'm saying. Okay, I think the problem is with the storage. I am giving the storage it as a comma separated, right? I think that's the problem. I will see this and I will explain you if I am right. Tuple input. Okay, now it is taking it. What it is doing is, I have this completely is an ordered set. They will say, okay, in the this is the text I'm trying to load it. Okay, this completely they will say it as an ordered set. Okay, here this one is a complete tuple, right? This one is the complete tuple. So in the storage, pick storage relation, pick storage the type, I should not specify any comma because it is not a comma separated text file. That is the reason is when I removed the comma it loaded completely into a one tuple and it is storing into that into this result. Okay, into the relation tuple input. When I give comma it is thinking that it is going to read a comma every end of the tuple and it will store it, but which is not the case. Okay, comma it will not actually understand because it is completely of single tuple. One record itself is a one tuple, that's why it will load as such. Okay, is this clear? So this is how you can give the tuples. Say for example in this itself I'll remove the brackets. I don't give it as a tuple form. Okay, it means my data set is not in the tuple form. It's a normal text file. Okay, with each records, I store that text. Any change you make in the tuple.txt, you have to again load it. Okay, no problem. Then dump the tuple input. Okay, it is not taking. It is going to read the data in the form of tuple only. Okay, text file it will not read it. That's why I wanted to show the difference. If your data is in this form, then you can specify how your schema is going to be. Okay, schema this is a every open each record is considered as a tuple. Okay, that's the reason the complete line it is going to read it and put it, and I am going to load this data as a tuple. That's what I'm saying. Till now I have taken the text data comma separated files or not, then it is loading into a tuple. So if I'm getting data like this, then how we are going to store it as a tuple this way. Okay, guys. Directly text file means it is a comma separated file. In the pic storage, you will give a comma. There you don't have to tell it is a tuple at all because it will take it's a text file only directly. I can try that also for if you wanted. I did not store this. See, it is not having, it is not in the form of tuple. It is a comma separated file. So in this line statement, I will give like this pick storage as this one. Okay, enter it, dump this. I think it will not take it. It will not take it. Why? Because text file, I'm saying it is a tuple format. Okay, schema given the definition. If I remove this tuple, it will take it as, it will work as primarily how it is. Okay, if you see the definition for tuple input, tuple input is the relation, right? I will describe it. What is the schema for that? See, it is showing it is of a tuple 0, and inside the tuple it is having all these fields. Okay, so if you are going to access this fields also, no, you can use this tuple underscore 0 dot id likewise. I will show you, okay, in the further classes. Okay, this is how you will load the tuple. And another thing is, yeah, I did not get you. It is also possible, Prakash, that you don't you can load the complete the customer data we are loading. No, I will show you. See, there will be this is a small kind of a sample information I have, so I am defining each field as this one. And it is also possible that we also have that state wise something, right? uh, yeah, some file we had, no, ls, yeah, state wise, this file. See here, say for example, normally you will get data sets like this completely. You will not know what is the each field. That time and all, what you can do, you can load it as without the, I'll go, or I will write it here only. Uh, State equal to load uh, that file name. Okay, whatever is the file name you will give. File name it is big, so I copy it and write using pick storage. We know it is commonly separated by comma, so we can give like this. That's all. We are not giving any schema here. Okay, this is also a way to load your data. Okay, then you can dump and check it will get dumped properly. Okay, but if you're trying to access this data, right, how do you access it? Since you don't know the field names, if you are knowing it, say for example, you are going to um, union, or if you are trying to filter this data set. Okay, relation we know. How do we filter it? Filter one, this is the relation name. After filtering, it will store the data into this filter one relation. Filter. Okay, the relation is what I gave the relation as, I forgot. State I have given as the relation, right? So I will create a filter one, filter, which relation I'm going to filter? State. Okay, uh, by, now we have to tell the field, right, which field you are going to tell. For that, actually there is this positional operators. Okay, dollars, it starts from $0 to $1. If you give the positional operators, then it will filter it, because we have not given the schema for this relation, state relation. That time you can go and use the positional characters. Is like it will be starting from $0, first column as $0, $0 equal to what the name, something like Tamil Nadu, or I think Bihar I will give. Okay, likewise you can do it. Some error is there in this, I think this one. Okay, likewise you can filter it. Positional character means the first position in the state wise. The first one, $0 will be taken as Andaman and Nicobar, and $2 will be taking it. It is like a variable. Okay, variable, like how we are specifying it using the positional numbers. Because if you don't know the, if you are not defining any schema for that, schema for schema for state I have not given, because a schema for state unknown. But even then, if you are doing some operations processing on that data set, how do we access a particular field? data using the positional characters. Okay, that's what you were asking, I think, right? So I will show you that also some more after this. Okay, now we have seen how do we load a tuple dataset, and now we will see how do we load a dataset in the form of a bag. Okay, bag means when you're trying to see a group, if you group any data and see it, it will show in the form of bags. Okay, I'll show you group. Okay, so this state dataset itself. Okay, I will take it in a relation. Group state dataset by, now I say by state we will group it by $0. Okay, $0 only we will group it. $0 is the state's name, so group it by $0. This is all fine. Then I will dump group one. Okay, see if you see it, that's what you cannot see it here. Then what I will do, I will group cust data we have, no, cust underscore data set, that relation we have, no, that I will group it by the first customer id. Okay, first column. Then dump this group one. What I'm doing is I'm not taking state. Okay, customer data relation I'm taking, right? Because it is small, so we can see how it is showing in the bag. Okay, so first field, based on the first field I am grouping, or based on a name we cannot say. Okay, city we can group it. If we say city, we will find which field it is. Okay, customer underscore one dot txt. See, city we will group it. So if this column is a $0, $1, $2, and $3 column, we will group it. Okay, so I will give it as dollar key. Anyway, cust underscore data will have a relation also, will have a schema also, because I have given the schema. Otherwise, if you don't have, you have not given the schema, based on the positional numbers, you can find the particular field. Okay, so I group this group one. Okay, see how you can see it is grouped by based on the city, and it has grouped and put it into a bag. Bag, I you remember I told like it will start and close with a open braces and close braces. If you can see Chennai, bag is nothing but collection of tuples, right? See, Chennai has more entries. So open the curly braces, and Chennai is stored in more entries. So if I say that this kind of a data set I am having it, it means you're getting an input data set from somebody who is having a grouped data likewise, and it is like multiple tuples are there in the grouped data. Like Mumbai entry is 3 4 people are there in Mumbai entry. In that cases, how do you load that set of data? How do you load that data set? That we will see it. Okay, so I have a bag. Yes. Yes, Prakash, what it is showing is whatever is with Chennai, those see, I'm grouping it by city, that is Chennai. So whatever the entry for Chennai, it all grouped together. That's what group it will do, no? Whatever is common all gets grouped together, and it gives us the results. That what it is doing. That everything will put it in a bag, and it gives us the result. Okay, aggregation will give into a bag. Okay, so if I have that kind of a data set, I have bag, I think. Yes. Yeah, this is the data set. Okay, this is that kind of a data set. If I'm getting it, then how do we load that type of data? That we will see it. How do we write schema for this type of a data? That we will write. We will see. Okay, so for that I'm going to bag load bag input. Okay, relation name is bag input equal to load. The file name is bag.txt. Using the pick storage, I'm not going to specify the comma separation here. So using the pick storage, as I'm going to say it is a bag which is also containing tuple. Okay, bag colon, bag will start and close with open and close braces, and inside this I will say it is a tuple. tuple, any name you can give. Okay, tuple 1. Okay, and after that I am going to give the definition for what are the values in the tuple. The tuple is containing three values, right? 1 John 19. Likewise it is containing, so id I will give as integer, name as I will give it as char array, and age I will give it as integer. Okay, so this is how we will give it the bag. You just close it properly. Why? Because this id is closed here, tuple is closed here, this bag curly brace is closed here, and the whole schema definition is closed here. Okay, semicolon, end this, no error in this. So we will dump the bag input and check it, bag input relation and check it. Okay, it is loaded as such, however we have given it. Okay guys, so this is how, if your data set is of a different types or the data models differently, which is coming to your pig, then you can load it this way. Okay, is this till now, is it fine? How do you load a tuple data set and how do you load a bag data set? Okay, also you can give, if you don't know the definition for the bag, you can give it like this: bag open and close braces. Okay, likewise. Okay, so now big bag date input I have changed. I don't know, say for example, I don't know the field names. That time I have changed it likewise. So dump the bag input. Bag input. Okay. So it is loading whatever is present in that inside that file. It is loading likewise. So okay, tell me, are you able to follow everyone? Venkana Babu. Okay. So if you give any assignments in the pig, we will be able to do. Later on you will be able to do, because we will take a problem statement and see it also. Okay, before going further, there is one other operator which is a for each. Okay, that we will see for each how it works. For each, like same for every uh, value in the data set, you will it will generate one or two values. Okay, for example, okay, before that, positional, did you people understand positional numbers? Say, if I load any data set and without any schema. Okay, I told no schema, sorry, describe cust underscore data. Okay, this is having a schema or the stage. If there is a no schema is a defined, then you can use the positional characters. Okay, and then display the result, say in that only. Okay, what I will do, state data set we have now, what is there in the state data set, I will see dump state. Okay, this is there in the state data set. I'll try to split. Okay, split this complete data set into two relation, put it into a two relations. Okay, so split relation as a new relation. No, the relation what I'm going to split is state. Okay, state, if I will say dollar 0, okay, equal to so like Goa, I'm saying. Okay, it split means it is going to divide into two ways. Okay, so what I will do, the another split what I will give, split dollar 1. Okay, relation name we have to give first. Here I made a mistake. Relation name you have to give. Split state into relation. Okay, relation, say relation 1. If dollar is a Goa, and in the relation 2, okay, relation 2, I will give if a dollar, we have the total samples, right? 1 is a greater than some number. It is of huge, right? This is like, I will give this one. Okay, like 1 more than this value. 15. How many digits were there in that? Okay, more, sorry, more than this. So split, I'm going to I'll just, okay. Splitting the state into relation one, if dollar zero is equal to, that is the first column, equal to Goa, and the second relation I am splitting with the total samples as greater than 15,000. Enter it. It is no problem. So we have two relations. We got two relations split into two relation. One relation will have rel 1. Okay, it will have all the data of the Goa. Right. And another relation we have a dump rel 2, which will have all the relations which are more than 15,000. I think this number is huge. I have given a small number in the split. That's why all are coming. It has a 2468, 2467, one digit only I am given. That's why it is coming like this. This you understood. Now why I'm trying to show here is, if you don't know about the schema, if you can see the data set how it looks like, then you can use the positional numbers and do whatever the operations on your data sets. That's the reason I showed this. Okay, now we will go to Foreach. Group everything you remember, I hope. Then we'll go to other one. Okay, what I'll take the student data set. I think I have a student data set. Okay, VI student. Yeah, student data is there. Okay, 1 minute. Student data is there. This small data set. This small text file. I will take it. In this, I will show you for each how it works. Okay, so I will create a relation. Okay, God, I came out. Control something I give, it came out. Big hyphen X local. I'll again go in. Okay, I'm going to use the student data set, data small set. So what I have to do, I have to load that first while using it, before using. So load, LOAD, load. That is the file name is, okay, sorry, student data.txt. Okay, student underscore data. This is my relation name. In the relation, I will do load this file. Okay, this is the file name, and using pic storage as, then I will give the ID, same thing, mostly because we are working on with those things. So ID, name, age, and city. I'll give ID. ID is int. Name is char array, or marks we can give. Okay, marks as integer, and city as char array. Okay, this is a loader. You don't have to check dump every time. Okay, what I will do, I will find the average age of the students in this data set. Now I have loaded into the relation student data. Okay, average equal to for each. Okay, for each, for that I will group it by, okay, group or some name I will give. Group 1 equal to, see, I cannot use a group itself. Okay, if I cannot say I group student underscore data by city. Okay, this will not work. Why? Because the group name, that is the keyword, okay, it will throw error, syntax error. The keyword and the relation name cannot be same. Okay, for that I have to give a different group name. Say I will give different relation name. First, student data set, I am grouping it. So when I check it, dump group 1. Okay, see, this is how it is a grouped based on the city. It is showing into the backs. This you understood, no? So Delhi is having three records: Suresh, and John. Okay, then afterwards, so what I will do, I will see the relation, like average for the age in each city. So the problem statement is average of age of each student, or average of age of students from each city. Like in Delhi, what is average age? Chennai, what is average age? So how do we get it? First, we have to group the data, then we have to find the average. So for each group the data, okay, in the group relation is a group 1, generate, I'll write it like this, generate average. AVG is a capital letter, and in which relation, student underscore age dot student underscore data. I will explain, okay, dot age. So what I'm doing here, I'm saying my problem statement is find the average age of a students in particular city. Okay, my data set is like this. In this data set, I cannot find the average age. Okay, okay, average marks I have given. No, it is not age, marks. Age would have been more appropriate, right? Because the data set for student data I have given as marks. Okay, like that only we will search. Okay, this one I have considered it as a marks. So each city, what is the average mark? Say for example, Delhi, we have a data, three records. Okay, what is the average of these three? It will give, right? For that, first we have to group it by Delhi, we have to group it by Chennai, we have to group it by Hyderabad, and the grouped data we have to find the average. That's why the statement is like this. Enter it. For each group, whatever the group we have done, you are going to find the average. Okay, average of marks. That is done. So we can dump and check the result. So it is giving the average for each city. This is clear. See, what I am doing here is three steps. I am doing it. First, I loaded the data, right? This loaded into student data. Then after loading, I want my problem statement, we understood that average or in each city we have to find. For that, I am grouping it by city. Then afterwards, what I did, I am finding the average. So these are the three steps we have to do. Okay, so you remember that how you will write an SQL query. Say for example, in MapReduce, if you wanted to find this solution, how you will write it? First, you have to do a aggregation. No aggregation, you have to actually from the reduce, this will be your reduce output. That output again you will send it to a another reduce. Okay, in your map reduce it will be like that. But here, if you can if you have to do it, then you can do it likewise easy. Three commands only are present. Okay, find the average from each city. Okay, this is how you write it. See, you don't have to dump every after every statements of the pig. Okay, pig scripts, you can start writing all the scripts, and finally if you give the dump also, it will give the same result. Okay, so what I told, if you remember it, with every pig scripts it will not start any execution, it will only do a compile, I mean syntactical analysis, I mean semantic check. Okay, that is syntax check. And this also will do a syntax check, and this also will do a syntax check. But the results will be stored in the relations, right? So whenever you do a dump of the average, it will give you the, it will start the map reduce. Inside map reduce, it will do all the things, the splitting and storing the data. Okay, passing it to the another reduce, all these things are taken care by the engine itself, you don't have to worry about it. Underlyingly it will use map reduce only. Okay, but final results will be given like this. Is this fine? So this is the aggregate function, one aggregate function, average you can see. So there is also like minimum, right? Minimum, maximum, min. Okay, min it will give error because min is going to be the your capital letter min. Okay, it should be capital letter min. uh, okay, relation name I will change it as a min. In each of the group I'm going to find the minimum marks. Okay, group data, you know, right, what it was resulting, or should I copy and see? Show dump group I will show. Group 1 it is not group. This is the group data, right? This I will copy it. See, this is the grouped data, right? In this, I'm going to find the minimum and the maximum marks. Here, I have given this as a marks, so it will give. I've written the query for the minimum and maximum as. See, this aggregate functions should be in capital letter only in big, okay, not the small letter. And in from the group, I'm going to find the minimum marks. Okay, if you dump and check, dump avj I have dumped. Again it has overwritten. Okay, minimum marks in the first group, right? Pune is 44, Delhi is 33, Chennai is 41, and Hyderabad it is 27. Okay, likewise it will give the results. Okay, maximum also you can find it. Okay, sum also you can find it. Okay, what I will do is we will check the sum. You can also pass multiple fields, okay, in this in this finding the average or anything. Okay, I will put this one minimum, minimum value, minimum marks, and also minimum ID if you are trying to find it. Okay, ID field I have given. Multiple fields also is possible. So it is throwing error for me. Student data dot, I have missed it. Just a moment. Okay, sorry about that. So in this ID also I am giving it, but it is still throwing error. Could not infer the matching function. Okay, say I will put some. Yeah, could not do that. I'm trying to give two values so that it will give two values in the tuple for each group. Generate minimum marks and ID. Okay, I think for that I have to do this one group also. I have to do it by two ways. By name and okay, same thing. I will try this way. So relation I will give equal to for each group one generate student underscore data dot name comma student underscore data dot city. Okay, this is fine. So for each group, I'm going to generate a two output, which is going to be the name and the city. That's what it is doing. So dump rel. So it is going to give for each of the group, it is going to give the name and the city. Okay, name of all and the city of this one, it is grouped and giving. But I tried to put the average, it will not come, I think. Average or min max. Average, min, max, and all works on the numerical characters only, right? So it will not work. It will not work that way. So sum, if I give sum of the marks and the sum of ID, it is throwing error. Okay, this I will check and tell because I remember giving these two together. So it will do a sum of the marks and the ID and give. Okay. So but it is not giving here now. Or I have to set it on this student relation, I think. Okay. Space I missed. It is still an error. I will check this one. Okay, I have taken note. In the next class I will rectify this. Like how we can give it two fields. Okay, for each. Okay, that is all from here. Hmm. Together also you can write it. One simple example like together means I'll start a relation for each group. Okay, group the value, generate the student underscore data dot name. How you have to refer the another relation's name is like this. Okay, student data, so that relation name, and I will also display the city. Student code data under dot city, and I also find the maximum of the same thing you can give of the student data's marks. Sorry, underscore data dot marks, rks. Okay, likewise I can do also. I can find out the sum of student marks. Okay, what you understand from this is, see, here whatever I'm giving is the another relation name and its city. I'm going to display it, and also it is going to give me the maximum of the student marks from the name and the city, from the city. Okay, and also because the group data is by group dot city. Okay, maximum marks of that city and the sum of the marks of the city also it will give. Okay, if I dump this and check, show you. Okay, see if you can see it with the statement, it has given the name. Okay, name is from the student data set Rita, and the two student data set city it has given. It has given the maximum marks. Okay, from the grouped data. Okay, and it has given the sum also. Since Rita is belonging to Pune, she has only one record. It is giving the same result. Otherwise, if you can see for Delhi, right, three are there. Maximum marks and the aggregated marks, that is the sum of the marks it has given. So likewise you can apply. So what we will do, we will take a case study, like there is a sample employee attrition rate data set I had taken from Kaggle website. Okay, that in that data set we will write a problems, we will find a solution for a problem statement, like how the problem statement will be like count the number of employees who are less satisfied with their job. Okay, likewise employee record count who are less satisfied or medium satisfied, it has all the informations or belongs to a particular age. Likewise we will write the problem statement, that we will see it in the next class. Okay, I will stop it here. So I will put all this whatever not executed, I've already executed all these things, the commands which we have worked out, like for each joins and those things, positional numbers, those things I will put it. Okay, you can practice it. Maybe that data in that and my data might be referring differing from what I show in the class, but it is more or less the same concept. Then how do we load the tuple and how do we load the bag kind of a data set also will be there. Okay, guys, I will close the session now. MapReduce, we will see it later on. Okay, we'll finish this